Studies, generally common last questions. Question number 4, we will start with 4. It tells that a solid disk with a radius or rotates at a constant rate, which is omega, and constant angular speed. Which of the following points on the disk have the greatest tangential speed? Greatest tangential speed. We know this disk is a rigid object, so omega for every single point is the same. Then tangential speed is going to be r times omega. Because omega is the same for all points, this is the object. Greatest r will have a greatest tangential speed. Of course, point A has the greatest radius. That's why point A will have the greatest tangential speed. Next question, question number 7. A disk is rotating about its center of mass. Point A is 0.6 meter from the axis of rotation, which is the radius of the point A. Point B is 0.12 meter from the axis of rotation, which is the radius of the point B, circle of the point B. One of the following is correct. Angular speed of point B is twice as much as A. So angular speed, because this is a rigid object, angular speeds are the same for every single point. That's why this is not correct. Tangential speed of point B is twice as much as point A. Because point B has twice the radius, one of them is 0.06, the other one is 0.12. So this is R, this is going to be 2R. Of course, point B, because it has twice the radius of point A, it will have a tangential speed twice the tangential speed of point A. This is correct answer. Centripetal acceleration of point B is twice as much as the point A. Centripetal acceleration equation AC is equal to R times omega squared. We are using omega because omega for a rigid object is the same. As R increases, AC for the point also increases because point B is twice as far as point A. Its centripetal acceleration is going to be also twice as big as point A. Yani B and C are correct answer for this question. The next one is question number 8, sorry. A horse on a carousel is 3.2 meters away from the center of the center, travels a distance of 16 meters. In the same time interval, another horse, which is 1.6 meters away from center, travels a distance of how much? So it's carousel is a rigid object. These horses are on this rigid. Because the carousel is a rigid object and horses will have the same angular displacements, so angular displacement of horse A and angular displacement of horse B will be the same. And delta theta for horse A and delta theta for horse B is going to be say delta theta is equal to delta S over R. I will calculate angular displacement for horse A first, which is given to 3.2 divided by 16, which is going to be, I think, 0.232 over 6, 0.2 meters of radian. I'm going to use now this equation, this angular displacement for horse P. The same angular displacement is delta S for horse P divided by radius. Another horse which is 1.6 meter away from the center, and R is 1.6 meter. Cross product, I can calculate distance traveled by the horse, which is delta S. Delta S is going to be R times delta theta. R is 1.6 for second horse P. Angular displacement is 0.2. So when we multiply them, result is going to be, I think, 3.2 meters. And next question is 11. Question number 11. It is a car is moving in a circular path with a constant tangential speed. If it is moving in a circular path, absolutely there is an AC circular path, and constant tangential speed means AT0, no tangential acceleration. VT constant. If VT is constant, no change in VT, no, then 0 AT. It has only centripetal acceleration. This is correct. It has only tangential acceleration, not correct. It has both centripetal and tangent, not correct. Okay, this correct answer is it has only centripetal acceleration. Question number after 11, 20. I will go 20. There are 3 horses on a carousel. Horse A is 0.5 meter, horse B is 1 meter, horse C is 1.5 meter from the center of the carousel. Which horse has the greatest centripetal acceleration? I'm going to the centripetal acceleration again, r omega squared. Why? Because these horses are on a rigid object. That's why all of these horses will have same angular speed. That's why as r increases, AC increases. Of course, which horse has greater distance from the center? Horse C is greatest distance, and the radius of the circle for horse C is the largest. That's why centripetal acceleration is going to be greatest for horse C. After 2023. A horse on a carousel, which is 3.2 meter away from the center, rotates 16 radian. This is the angular displacement for the horse A. In the same time interval, another horse, which is 1.6 meter away from the center, rotates in radians. So carousel is again a rigid object. In the rigid object, every single point have the same angular displacement, angular speed, angular acceleration. So if one horse has an angular displacement of 16 radian, other horses will have the same angular displacement. No need calculation in here. After 23, 31. Which of the following statement is correct? Earth revolves around the sun perfect circular orbit. No, not perfect circular orbit. Near the circular orbit, yani elliptical orbit. This is not correct. Gravitational force produces acceleration. Of course, every force produces acceleration. Gravitational force produces gravitational acceleration. This is correct. The acceleration of the Earth is 0 while revolving around the sun. Impossible. There is an AC because Earth is moving on a nearly circular orbit. There is a centripetal acceleration, not 0. The net force on the Earth is 0 in its orbit. Impossible. If there is a centripetal circular motion, there must be a centripetal force. The centripetal force is the gravitational force. So this is the B is the correct answer. And 40. The magnet object is moving in a circular path. The magnitude of the tangential acceleration and the centripetal acceleration of the object are equal. What is the angle between the tangential velocity and total acceleration? We know there's an equation tangent theta, which relates to the angle, which calculates the angle between the direction of velocity and total acceleration, AC over AT. Question says that centripetal acceleration AC and tangential acceleration AT are equal. If they are equal, their division is going to be 1. And which angle has a tangent 1? If you check that inverse tangent 1, theta is equal to tangent inverse 1, which is going to be 45 degrees. And after 40, 49. Which of the following sentence describes the path of a moving body whose acceleration is constant in magnitude at all times and perpendicular to velocity? Only one acceleration is perpendicular to velocity. It is the centripetal acceleration, AC. And acceleration is constant in magnitude. AC is constant in magnitude means V squared over R must stay constant. So it's a circular path. And if VT and R unchanged, AC is constant in magnitude. With unchanged means it must move with constant speed. An object must move in a circular path because of the centripetal acceleration with constant tangential speed because AC is constant in magnitude. Car is at constant speed while rounding a turn. C is the correct answer. After 49, we go 52. A solid disk with a reduced R rotates at a constant rate omega. Which of the following points on the disk have the greatest angular speed? Because disk is a rigid object, every single point will have same omega. All points have same omega. After 52, we do 56. A girl sits in a tire that is attached to a overhanging tree climbed by a rope of 2.1 meter in length. The girl's father pushes her with the tangential speed Vt, and girl's mass is 39.5. What is the magnitude of the force that maintains her circular motion? And centripetal force is the question. Centripetal force equation, mv squared over r. And here is the length of the Rho is going to be the radius of the circle, because as this is the length of the rope, this is the extra rotation. The cylinder is swinging like this, so that's why length is equal to R. M is given 39.5, Vt is given 2.5, but squared divided by radius is, which is length of the rope. We are going to use calculator. 39.5 times 2.5 squared divided by 2.1, answer is 117.5, yeah, almost 118 lift. And after this question number 57, yeah, 63, 57. Find the average angular speed of the wheel that rotates 30 times in 12 seconds in revolution per seconds. So this is angular displacement in revolution. This is time, delta t. So I'm just going to choose omega delta theta over delta t, which is 30 divided by 12. So 30 divided by 12 is going to be 2.5 revolution per seconds. And 63. Two identical trucks are attracted to each other with a gravitational force of 6.7 times 10 to the power negative 4 Newton. The trucks are separated by a distance of 3 meters. What is the mass of one truck? So gravitational force between two objects is capital G, mass 1, mass 2 divided by r squared. Because each trucks are identical, they will have the same mass, m times m divided by r squared. So it becomes, Fg becomes G times m squared. Some students are writing this one 2m. No, m times m, not 2m, m squared divided by r squared. I will leave m squared alone. M squared is going to be Fg times r squared over capital G. After that, we will get the root. Let's calculate m squared first. Fg is 6.7 times 10 to the power of negative 4. R is 3, but squared. Ng is 6.67 times, so not g squared. Why did you write g squared in here? It's just g. 6.67 times 10 to the power of negative 11. So let's calculate m squared first. 6.7 times 10 to the power of negative 4 times 3 squared divided by brackets 6.67 times 10 to the power of negative 11. So answer is, this is 90,000 for 405 kilogram squared, but we should get the root because once m squared, when we get the root, take the root of the answer, it's going to be 900, m is equal to 9,508 kilogram. Yani 9.5 times 10 to the power of 3 kilogram is the correct answer. And next question is test 2. Now we will go with test 2. Some questions in test 2. I will start with question number 5, then 19. Question number 5. The tube within a washer goes into spin cycle starting from rest, and omega initial is 0, reaching an angular speed omega final is 12 radian per second and 8 seconds delta t. What is average angular speed? And omega average is the question. So omega average is, okay, so this is not omega average, angular acceleration average. So not omega average. It's very easy one, in fact. Alpha average is the question. Alpha average is equal to omega final minus omega initial divided by delta t. Final angular speed is 12 pi. Initial is 0 divided by delta t is 8. It's going to be 12 pi over 8. If we simplify by 4, divide by 4, 3 divide by 4, 4. Pardon, 2, it's going to be 3 pi over 2 radian per second squared, and it's the correct answer. And 19. 19. An object is moving a circle at a constant speed. Which of the following is not true for an object? Circle, moving a circle, absolutely there's an AC. With constant speed, AC exists, but AT 0. And also alpha 0. Its centripetal acceleration points towards the center of the circle. Yes, all centripetal acceleration points towards the center, but this is not the answer we are looking for net. Its tangential speed is constant. Constant speed, tangential speed constant. Correct, but it's not the answer. Its velocity is constant. No, velocity is not constant because moving a circular path in front of you in a circular path, its velocity never becomes constant because direction of the motion continuously changes. Not. Centripetal force acts on the object, of course, must act on the object because object is moving in a circular path. And question number 22 and 26. A car's tire rotates at an initial angular speed of 26.2 omega initial, and the driver accelerates with a constant angular acceleration and reaches an angular speed of 54.6 radian per second. What is the average angular speed? Omega average is the question. So if it is a constant angular acceleration, object is speeding up uniformly. Remember, we drew the delta T equation 1/2 omega initial plus omega final times delta T. When I write this, because I said that this is omega average. So when you add initial and final speed and divide by 2, you calculate omega average for uniform accelerating and decelerating and constant angular acceleration motion. So omega initial is 26.2, omega final is 54.6. Add them, divide by 2, you will calculate the answer. 26.2 plus 54.6 divided by 2, 40.4. Omega average is 40.4. Next question after 22 is 26 and 29. 26 and 29. 26. The gravitational force between two masses is 36 Newton. What is the gravitational force if the distance between them is tripled? We know gravitational force equation. Fg is equal to capital G mass 1 mass 2 divided by r squared. According to this equation, r and Fg are inverse proportional to square of the separation. Now, initial value is 36 Newton and is equal to, say, 1 over r squared, but later, tripled. R is tripled, so a final gravitational force I will calculate, but with a radius which is 3 times of the initial one. So I will get the square of 3r. It's going to be 1 over 9r squared. So 1 over r squared is 36. So I will write in here 36. If we divide 36 by 9, because the denominator is 9, it's going to be 4 Newton. 4 Newton is the correct answer. After 26, we do 29 and 38. 29. Find the force of friction needed to keep 3,000 kilogram car traveling in an exit ramp of 100 meter radius with a speed of 60 kilometers per hour. This is mass. This is radius. This is VT. Find the force of friction. Of course, we are not going to use the equation force of friction. We will use the equation for centripetal force because force of friction is keeping this car in a circular path. That's why force of friction is the centripetal force. I will use centripetal force equation v squared over r. This v is in kilometer per hour. So convert it to the meter per second. 6 divided by 3.6. If you divide kilometer per hour by 3.6, we will convert it to meter per second. That is 16.7. After that, insert in the equation, calculate centripetal force, which is at the same time force of friction. M is 3,000, V is 16.7, but square divided by radius is 100. I'm going to use the calculator, multiply by 3,000 divided by 100. Answer is 8,323. That is the correct answer. After 29, we go to 38. What is the angular displacement of the minute hand of the clock for 30 minutes? Minute hand completes one revolution in 60 minutes. So 60 minutes, one rotation. Yani one rotation, 2 pi radian. 2 pi radian. So if one rotation is 60 minutes and 2 pi radian 60 minutes, 30 minutes, how many radians? First product, half. And 60 divided by 2 is 30. So 2 pi divided by 2 is pi. Answer is pi radian. And next question after 38 is 41. So Earth is rotating 360 degrees every 24 hours. What is the angular displacement of a person standing at the equator for 4 hours in terms of revolution? Then 360 degrees, one revolution. So one revolution of a man on the equator takes 24 hours. So in 4 hours, how many revolutions? First step, x times 24 is equal to 1 times 4. So x is going to be 4 over 24 divided by 4, 1 divided by 4, 6. 1 over 6, revolution. T. After 41, 52. A mass attached to 50 centimeter string is rotating with a constant angular speed in a circular path exactly 40 times angular displacement delta theta in 1 minute, yani 60 seconds. What is centripetal acceleration? AC. So AC is going to be, so r omega squared, but we should first calculate omega. R is given, omega must be calculated. This information is enough for calculating omega. It's moving constant speed, so omega average will be equal to delta theta over delta t. Delta theta is 40 times 40 revolutions. Each revolution is 6.28 radian. We convert it to radian divided by 60 seconds. Let's calculate omega first. 40 times 6.28 divided by 60. It is 4.19. And average angle is with 4.19 meter radian per second. After that, apply this equation for AC. AC is going to be R 0.5 times 4.19 squared. Okay, answer is going to be 8.76. 8.76, yani is the correct answer. After 52, we go 54. An airplane is flying in a vertical circle at a speed of 120 meters per second. So vertical circle, let's draw a vertical circle like that. Okay. With a speed of Vt, maximum force exerted to pilot's body by the plane is going to be 6 times of its weight. Maximum force X at the bottom of the vertical path right here. And it's moving some tangential speed. 2 force X on the pilot's body. One of them is gravitational force, always downward. Second force is the Fn provided by the seat. And at this position, we can calculate centripetal force. What is the minimum radius of the plane's path? So R is the question. In here, Fc is equal to Fn minus Fg, because Fn is pointing to center positive, Fg is array negative. So Fc, and also Fn is given. Yani, the force acting on the pilot's body is 6 times of his weight. Yani, this is Fn, in fact. Fn at this position is 6 mg. Then write Mc mv squared over R. Fn is 6 mg. Fg is mg. So continue. So then, which means mv squared over R is going to be 5 mg. So simplify m's, get R, write R equation. R is going to be v squared over 5g. V is 120 squared, 5g, 5 times 9.81. So let's calculate the answer. 120 squared times 5 times 9.81. Answer is going to be 706 Sorry, what's the R is equal to 706. Where did I get this? mv squared over r, 6 mg minus mg, m squared over r, 5 mg, m's will simplify. So r is going to be v squared over r, 5g. So we calculate them. 120 squared divided by 5 times 9.81. Answer is 193, sorry, 293 meters. Yani almost C. And next question, after 54, it's going to be 65. What is when the arc length S is equal to length of the radius R, the angle theta is its definition of 1 radian. So on a circular motion, the radius and arc lengths are equal for angle, which is when 1 radian. It's definition of 1 radian. And after 65, we go with 66. The tube within a washer goes into its spin cycle starting from rest, now pi radian, and reaching an angular speed of 9 pi radian, omega initial, so 9 pi omega final. So we are going to calculate how many revolutions delta theta is equal to. So omega initial is pi radian, 9 pi divided by 2 is the initial plus final divided by 2 multiplied by delta t. So delta theta is going to be 10 pi over 2, 5 pi multiplied by delta t, which is 7, which is going to be 35 pi radian, but we should convert it to revolution. Delta theta in revolution is going to be 35 pi over, which is going to be 2 pi. Yani 35 divided by 2, 17.5 revolutions is the correct answer. Okay, now let's continue with the problems, test trick problems. I will continue with them. Question number 2, test 3. Question number 2. A 25 kilogram pail of water is rolled in a vertical circle. What is the minimum speed in what it can be moving at the top of the circle? So in here, the water will not fall out and it will stay in the pail if the radius of the circle is 50 centimeters. So if we want to keep the water inside the pail, there are going to be two forces. One of them is Fg, the other one is Fn. Minimum speed at minimum speed, Fn is going to be 0. Yani only centripetal force acting on the water must be gravitational force. Fc is equal to Fg. At this position, minimum speed. If speed is less than that, this water will not stay in the pail. So mv squared over r is mg. M's will simplify. Minimum speed squared is going to be rg. After that, we will get the root and we will find how much is this minimum speed. R is 0.5 50 centimeters, G is 9.81. After that, get the root. Let's check how much. 0.5
it's 2.2 meter per second.
2.2 meter per second, which is A. Next question, most ask me, is question number 6. This question, yeah. A roller coaster car of 515 kilogram rolls up a hill of the radius of curvature 15 meter, has from the highest point with a speed of 4 meters per second, like that. This roller coaster car in here. It passes with 8 meters per second, but at this position, two forces acting on the car body. One of them is a gravitational force, but normal forces away from the road, which is Fn. A weight scale is placed on the road at the highest point of the hill. How much does it read? Weight scale always measures Fn. That's why questions if I calculate Fn at this position. The centripetal force at this position is F G minus Fn, because Fg is towards the center positive, Fn is away from center negative. Because I will calculate Fn, I am going to replace Fn and Fc. Fn is going to be Fg plus Fc. Fg is mg, Fc is mv squared over r. You can write them or just take the common parentheses of m. So m parentheses, it's going to be m parentheses g plus v squared over r. After that, you are going to apply your calculator. M is given 515 times in bracket. G is 9.81 plus v squared, which is 8 square 64 divided by 64 divided by G, which is r. R is how much? R is 50 divided by 15, 64 divided by 15. Answer is 7.23. 7,000. Of course, I did that incorrect, I think. So mg, m is 515 times. Pardon, this must be negative, so not positive. Because when I transfer Fn to the left, it becomes positive. Fc to the right is become negative. Is going to be negative. Is going to be negative. Not positive. So m 515 times bracket 9.81 minus v squared. V squared is 8 squared, which is 64 divided by r, which is 15. Answer is 2,855. Yani A is the correct answer. And let me check my battery life, how much? 48, it's good. We stopped in here, we start charging. Now let's continue with question number 11. A bicycle rides along a circular track with an average angular speed of 0.314 radian per second. This is omega. The cyclist travels around blah blah how many the track. This is in fact asking about revolution because 1/3, 2/3, 3/4, 1/4. These are revolutions. Yani calculate angular displacement in revolution. Omega average is given delta theta over delta t. Cross product, we will calculate delta theta. Average angular speed is 0.314 multiplied by 5. But this is radian. Yani 0.314 times 5, it is 1.57 radian. So in revolution, to calculate radian to revolution, convert to radian, we should divide by 6.28, 1.57 divided by 6.28, divided by 6.28, which is going to be 0.25. 0.25 revolution, yeah, it's 1/4. 1/4 revolution, 0.25, yani D. After 11, I will continue with 13. The average value of the free fall acceleration on the surface of Earth is 9.81 meters per second squared. What is the magnitude of the free fall acceleration at an altitude of equal to r from the surface, where r indicates the radius of the Earth? So this is Earth's surface, and the radius of the Earth is r. At the surface, it is 9.81 is the free fall acceleration. If you want to calculate, question is asking, what is the magnitude of the free fall acceleration at an altitude r from the surface? And from surface, we will go one more r. So, of course, distance is going to be to the center, 2r in this case. What is g in here? So we know g equation. G is equal to capital G, mass of the planet divided by square of the distance from the center, and radius of the circle. Initial value is 9.81. When the radius is r squared, it is 9.81. But next final g is going to be when we insert instead of r, because r changes to 2r, 2r squared. So it's going to be 1/square root of 2 is 4, r squared This 1 over r squared is 9.81, as you see. I will insert instead of 1 over r squared 9.81, because 4 is in the denominator. 9.81 divided by 4, it's going to be 2.45 meters per second is the uniform acceleration at a distance of 2r from the center. And after 13, 14, a car is traveling 30 meters per second, undergoes constant negative acceleration of magnitude 2 meters per second squared when the brakes are applied. So what is the angular speed of the car's tire after 12 seconds? This is delta t, this is initial linear speed, this is linear acceleration. But final angular speed is the question. There are two ways. You convert this to rotational quantity, or first calculate linear quantity, then convert rotational quantity. Let's do it like this. I will first calculate omega v final by using the linear form of the kinematic equation, a times delta t. After that, I will convert this v final to omega final in the ordinary for an object. So v final is equal to v initial 30, because acceleration is going to is negative 2, delta t is 12. So it's going to be 30 minus 24. Yeah, and v final is going to be 6 meters per second. Then, because question is asking angular speed, that's for a rolling object, we know that v final is equal to r times omega final. Omega final is equal to v final divided by r. V final is 6, r is 30 centimeter, 0.3, which is going to be 20 radian per second. You can also go this way. We're calculating omega final. After 14, 15. MS attached to 50 centimeter string starts from rest, yani initial angular speed is 0. Rotated in a circular path 1 minute. Delta t is 60 seconds. Reaching a final angular speed, omega final, which is 8.4 radian per second. How many turns does it complete in time 1 minute? How many turns? Yani angular displacement. Initial final value delta t is given. Of course, I am going to second kinematic equation, 1 over 2. Omega initial plus omega final multiplied by delta t. So after that, we can find it first in radian, 1 over 2. Initial is 0, final is 8.4, delta t is 60 seconds. So it's going to be 8.4 times
252 radians.
152. Delta t is equal to 152 radians.
200 hocam.
Okay, 252 radians. Then turns is divided by 6.28. And 252 divided by 6.28. Answer is, I think, almost 40. 40
Yes.
revolutions, yeah, and 40 turns, revolutions, radians, turns. After 15, we will continue 22. 22, a remote control cars will accelerate at alpha 22.4 radian per second. So if the wheel begins with an angular speed, which is omega initial, what is the wheel's angular speed after exactly 3 full turns? And delta theta is 1 revolution or 1 rotation, which is equal to 6.28 radian. So we will use, of course, kinematic equation, but the fourth one, because in here no time is given, angular displacement is given. So we will find final angular speed, kinematic equation without time, in final squared, the initial squared, plus 2 alpha delta theta. So we final squared, the initial is it starts from rest, I think, is it? Begins with an, not, begins with 10.8. 10.8 squared plus 2 alpha is 22.4, delta theta is 6.28. So omega final squared 10.8 squared plus 2 times 22.4 times 6.28. Result is 394.98. Get to it. Almost 20. So omega final is going to be 20 radian per second. And is the correct answer for this question. And after 22, 28. 28. An object is moving in a circular path. The ratio of the linear acceleration to the angular acceleration and division of linear speed, sorry, not ratio of linear speed to the angular speed, yani Vt over omega is the question. Maybe we remember that. Vt is equal to R times omega. So if we divide by omega and omega, so Vt over omega is R radius of the circular path. After 28, it's going to be 29 and 30. We'll do 29 and 30. 29, a 2 kilogram ball is attached to a string and a whirl in a vertical path. When the ball passes through the lowest point of the path, the tension on the string is 49.6 Newton. What is the tension on the string when the ball is at the top of its path? So as ball is more in a circular path, like that. So at the bottom, tension is given, and at this position, tension is given. We know Fgx on the ball, also tension x on the ball. This tension at this position, 59.4 newtons. So when this string goes up in here, what is the tension at this position? Let me say this is tension 1 because tensions are different. In here, we have F tension 2 and also Fg. At this position, at the lowest position, centripetal force is Ft minus Fg. So Ft is 49.6 minus mg. M is 2, G is 9.81. At this position, we can calculate centripetal force, 49.6 minus 2 times 9.81. Answer is almost 30 Newton. Question says that consider that speed of the ball is constant. And if the speed of the ball is constant, mv squared over r, yani centripetal force will stay constant. At the top, we will have the same centripetal force. Then centripetal force at the top is going to be F tension 2 plus Fg. Then I will calculate this. So I have to transfer Fg to the left side. F tension 2 is going to be Fc minus Fg at the top. Fc we calculate is almost 30. Fg is m times g, 2 times 9.81. So 30 minus, okay, how much?
Hocam, result is almost 10.4.
10.4 Newton is the answer for this question. And after this question, after 29, we have 30, 30, 31, 32. 30, 31, 32. A 13,500 Newton car. Let me check the button on my computer. Okay, it's okay. A car traveling 54 kilometers per hour runs a curve of 100 meters. The coefficient of static friction between the flat road and the tire is 0.5. How long can the car drive safe on the road before skidding? It's accelerating 1.5 meters per second square. So if the car is moving on a circular path, static friction force is the centripetal force. So mu s is going to be AC over G is the equation which I will use for finding the final angular speed, final linear speed the car can have without skidding, because initial linear speed is given. I will calculate, I will convert this to per second, 54 divided by 3.6, short day, 54 divided by 3.6, it is 50. Yeah, and this initial linear speed is 50 meters per second. Then it accelerates with an acceleration of 1.5 meters per second, and gets a final angular speed. Then this final linear speed I am going to calculate. V squared, V final squared over R is AC, R times G, cross product. We can calculate what is this final speed squared, mu s R G. After that, we'll get to it. So final speed, which the car is still on the road, is mu s is 4.5 times R is 400, G is 9.81, So to 981, we get the root of this number, 31.3. Yani almost 31 meter per second is the final speed. Still the car is moving in a circular path. After this speed, it will start skidding. Then I can calculate how long will it take, yani delta t, by using kinematic equation. V final is equal to V initial plus A delta t. Final is 31. Initial is 15. A is 1.5. Calculate delta t. Delta t is going to be 31 minus 15, which is 16. 16 over 1.5. So 16 over
10.9.
10.9. Yeah, it's the almost 10.9 is the correct answer. 31. The world's largest Ferris wheel has a radius of 15 meters. Each gondol, yani cabin on the wheel takes 1 minute and 60 seconds, delta t. To complete one revolution, yani 6.28. When it is running at full speed, what is the centripetal acceleration of the gondol, yani AC? I can calculate AC by R times omega squared. R is given, but omega must be calculated. I can calculate omega as well because it is moving with constant angular speed. Omega average is delta theta over delta t. Delta theta for one revolution 6.28. This one revolution takes 1 minute, yani 60 seconds. So omega average is going to be almost 0.1, I think. 6.28 divided by 60. 0.105. 0.105 radian per second. After that, AC is going to be R times omega squared, 50 times 0.105 squared. Answer is going to be 0.55 and 0.55 almost radian meter per second squared. Yani is the correct answer. After 31, 32, which of the following quantities is zero for an object on a circular path with constant tangential speed? Centripetal acceleration never zero because circular path centripetal always exists. This is not correct. Because constant tangential speed, Vt constant, which means At zero. Tangential acceleration zero, this is correct. Angular acceleration is also zero because At and alpha directly proportional. If tangential acceleration is zero, angular acceleration also zero. Both tangential and angular acceleration, this is the correct answer for this question. After 32, 37. We go to 37. What is the orbital speed of the Earth around the Sun at a distance of blah, blah, blah? Orbital speed means tangential speed. We can get tangential speed equation by using the centripetal force definition. Fc for planet is gravitational force. Fc, m of the planet, v squared of the planet divided by radius of the orbit. And Fg capital G, mass of the sun, mass of the planet divided by r squared. So mass of planet will simplify, Rn squared will simplify. V squared is equal to capital G, mass of the planet divided by radius of the orbit. And all are given. V squared is going to be capital G, 6.67 times 10 to the power of -11. Mass of the star is, which is sun, 1.5 times 10 to the power of 11, divided by radius of the orbit, which is, mass of the sun is 1.99, 10 to the power of 30. Radius is 1.5 times 10 to the power of 11. So now let's do the calculator. 6.67 times 10 to the power of -11 times 1.99 times 10 to the power of 10 to the power of 30 divided by bracket 1.5 times 10 to the power of 11. Close the bracket. So when we get the root of this answer, the result is going to be 2.9 times 2.97 times, yeah, 2.97 times 10 to the power of 4. Question on 37 is this. And 38 and 40. 38. The body that moves in a circular path with constant tangential speed, circular path at AC. Constant tangential speed, AT0. In equilibrium with, because first we should know if there's an acceleration, AC or AT, no equilibrium. Yani in equilibrium is not answer. Not in equilibrium, not in equilibrium. With an acceleration of constant magnitude, with a zero, impossible. If there's an acceleration, there is no equilibrium. Yani not equilibrium in a zero acceleration, it's impossible. Zero acceleration means equilibrium. So then this cannot be correct. Just one choice is left. Not in equilibrium with an acceleration of constant magnitude. Why constant magnitude? Because AC is V squared over R. Only AC exists. And V is constant. If V is constant, then AC must be constant in magnitude. 37. 40, 45, 48. 40, 45, 48, 40. An object moves in a circular path with constant tangentials. Again, circular path AC, constant tangential speed is AT0. Object's velocity is constant. Velocity is not constant circular path. It's impossible because direction is continuously changing. On a circular motion, constant velocity cannot be taught. Object's total acceleration is constant. This could be possible, constant in magnitude, however, but in here, not literally not constant in magnitude. Just constant is not correct because AC exists, but AC's direction is continuously changing, sometimes to the left, sometimes to the right, sometimes up, sometimes down. Its direction is continuously changing. That's why this is not also correct. Object's angular acceleration is constant and greater than zero. If AT is zero, alpha must be zero because AT and alpha directly proportional. If one of them is zero, the other one is zero. It is constant. No, not constant. It's zero. This is not also correct. The object's angular speed is constant. If the tangential speed constant, angular speed is also constant because tangential speed is equal to R times. Already, if one of them is constant, the other one is also constant. This is correct answer. And the question after 40, we will continue 45 and 48. 45. A satellite traveling at a constant orbital speed around 3.14 kilometers circular track. The centripetal acceleration of the satellite is given. What is orbital speed? Orbital speed, again, tangential speed. We will find this. So centripetal acceleration AC is given. AC is equal to VT squared over R. If I want to calculate VT, cross product, VT squared is equal to R times AC. AC is given, but R must be calculated. This is not R, this is the circumference. Circumference is equal to 2 pi R. This is kilometer multiplied by 1,000, 3,140 meter, 2 pi 6.28. R is the question. I think R is 500. If I calculate this before, that is 500 divided by 6.28. Yeah, 500. R is 500 meter. Then I can insert this equation. 500. AC is 0.05 multiplied by 0.05. Answer is 25. Yani VT squared is equal to 25 at third. VT is going to be 5 meter per second. Is the correct answer. And 45, 48 is the next question. As a golf club is swung, the linear acceleration of the club head will be large. So golf club is something like this. There is a head, and you are holding from this point. This point is the axis of rotation, and then it's swung around this point, something like this. So we are going to calculate linear acceleration, yani tangential acceleration, in fact, linear acceleration here. Omega, of course, linear acceleration is alpha. If there's a linear acceleration, there must be an angular acceleration because they are related. R times alpha is AT. So according to this, club head undergoes large angular acceleration. If this is large, AT is also large. And both are large. Large, this is correct. Golf ball hit a shorter distance, and R gets shorter. If you get R shorter, a smaller AT, but we want it to be large, this is not correct. Club head undergoes small angular acceleration, angular acceleration, small linear acceleration. So this is not correct. So A is the correct answer on this question. 48, 50, and 51. A mass attached to 50 centimeter string starts from rest and omega initially 0, rotating in a circular path exactly 40 times. This is delta theta. In 1 minute, which is delta t. What is average angular speed? Omega average is the question. So this is a constant speed motion. Is it constant speed? No, not constant speed. Average angular speed of the mass is asked. Set for mass is rotating in a circular path exactly 100 times. If average angular speed is the question, of course, delta theta over delta t, what we are looking for. It starts from this, but we don't care about how it starts. So if average angular speed is asked, delta theta over delta t is the question. So delta theta is 40 times, 40 revolutions. Every one revolution is 2 pi. Because choices are given pi, I am going to write not 6.8, I will write 2 pi, divided by delta t, which is 1 minute, and 60. So these zeros will simplify. These 2 and this 6 will simplify. In here 3. Omega average is going to be 4 pi over 3 radian per second. Yani is the correct answer. And last question is 51. A certain loop coaster has a vertical loop just like this with a radius of 40 meters. What minimum speed at the top of the loop? At the top of the loop, below the track, and right here. When the car is in here, what minimum speed? F minimum, V minimum is the question. Will make a 60-kilogram rider feel weightless. Feeling weightless. There are two forces acting on the car in this position, Fg and Fn by the track. Fn is downward this time because track is above. But if you want to feel weightless, Fn must be equal to 0. This is the condition for feeling weightless. So the only force acting on the coaster is going to be Fg as a centripetal force. Fc is going to be Fg. Fcm, the minimum squared divided by R is mg. M's will simplify. The minimum speed squared is R times G. R is 40. G is 9.81. So get the root. So 40 times 9.81. After that, take the root. 19.8. And V minimum is equal to 19.8 meter per second. So with this question, we finished chapter 1. Chapter 1 tests all of that.